gonna need to sit down now, Lincoln. Just sit down. Okay, so there's one problem there. It's actually two, I guess. It's got a little chart with it. And it says, according to the numerical model, what has been the trend in females joining the workforce since 1954? All right, so let's look at the female numbers. We're on the last page of our old notes, because we have couple problems stuff here. Last page of our old notes. What has been the trend in female employment? What do you think?
It increases.
It's increasing, definitely. Now, this is old data from 1954 to 2004, but can anybody explain that? Why the number of women working seems to be increasing? How many of your moms work outside the home? How many of your mothers have jobs outside the home? Okay, if they would have asked that question of my senior class back in 1976, 77, do you know how many kids would have raised their hands? None of them. None of our parents. Now, I lived in a farming community, so it wasn't like an urban environment like we have here, but moms didn't work back then. Moms worked at home, raising the kids and growing the garden and doing the laundry and all that stuff. But in my lifetime, women have started joining the workforce in droves. Look at the men numbers. What's happening to the men numbers?
They're decreasing.
They're decreasing because as more and more women went to work, more and more dads stayed home. Let's skip B, we don't need to analyze that data. Number 2, comparing cakes. A bakery sells a 9x13 cake with the same price as an 8-inch diameter cake. All right, so you walk into the bakery and you need to buy a cake. The round cake is twice the height. Which option gives the most cake for the money? So you walk in and you see a regular rectangular like sheet cake, and you see a layer cake, a round layer cake, and they're both the same price. You want to get obviously the best deal. So what's your thought? How would you figure that out? How would you decide which one? Assuming they were both beautiful and they were both the right flavor and everything, how would you decide which one to buy? Okay, we want to get the most for our money, right? Okay, how can we figure that out? How can we figure out let's just look at this cake. How can we figure out how much cake there is there? Not area. Not area. Area is like just this flat surface right here. If I want to know the amount of cake I have, then I want the volume. Then I want the volume. Now, I don't know how thick this cake is, and it doesn't matter because I know this is twice as high. So just for argument, let's say this is 1 inch high. So it's 9x13 by 1. Anybody remember how to find the volume of it's called a rectangular solid, a box? Length times width times height. So, what's 9 times 13? 117 cubic inches. So whatever they charge me, I will be getting 117 cubic inches of cake with that deal. Now what about for this one? This is your round layer cake, 2 layers, so it's 2 inches thick. How do I find the volume of that? What shape is that? Well, the top of it is a circle, but if I put the whole thing together, what shape is it? It's a cylinder. It's a cylinder. And the volume of a cylinder is pi r squared h. So my radius is what? Now it said 8-inch diameter, I think, yeah. So the radius is, 8-inch diameter. So the radius is 4. Square root would be 16. And the height is 2. So let's see what that is. Pi times 16 times 2. That's 100.53 cubic inches. So assuming that both cakes are lovely and they're both the right flavor, which one should I buy? The sheet cake, the rectangular one, because I'm getting more for my money, right? Same price, getting more for that one. All right, now let's look at our new notes. And here is a review problem. So everybody's gonna wake up, look alive, participate here. Somebody said we have visitors in the building today, so we wanna look like this is your favorite place to be. What do you think? How do you wanna solve this? What would be an idea? Oh, come on, you guys, we did a bunch of these in the last unit. You didn't need to do these.
Common denominator?
Well, we could. It might be easier in this case, it's kind of the same idea, but what if we just multiplied everything by 3? Would that take care of it? We just multiplied everything by 3? So then we would end up with 3x squared minus 12x minus 1. Now what do you want to do with that? You know what to do with that. I heard somebody say it, quadratic. Isn't this an x squared equation, you guys? Now, if you want it, this one doesn't factor, you can probably tell that, but you can always look at it and try to factor it. But the quadratic formula will always work. And do you know what? There's some of us that still don't know the quadratic formula. You're gonna keep on missing those problems forever. You need to learn the quadratic formula. What does it say? Negative b plus or minus the square root of b squared, which is 12 squared, minus 4 times a times c, all over 2a. It isn't just the radical that's over the 6. It's the whole shebang. So what do I have under there? 156. Now, some of you, look, listen, try to focus here. That doesn't cancel. I know you want to, but you can't. Now, maybe we'll be able to, after we break this down and get a number out here, but we gotta have a number out here before we start canceling. So let's look at 156. What happens with 156? Two goes into it. How many times?
78.
78. 2 goes into that. How many times?
39.
39. 3 goes into that. And then I think I'm done. So out can come a 2, and in will stay a 39. Very good, these 2 leftovers. Now can I cancel? Yes, not everything, but I can take a 2 out of all of these. Look, all 3 of these spots. So 2 goes into here, 6, 3, 1. So what is the final answer that you're gonna write on the answer blank? 6 plus or minus square root of 39. You can put a 1 there if you want, but you don't need to. Over 3. No more canceling. You have to be able to do all 3 spots. Alright, that's not so bad. What do you think about number 2? Or B, letter B here. What do you think about him? What? I would FOIL this out for sure. So x squared minus 2x plus 1x minus 2 plus 1. First outside, inside last. Now what? I would clean that up, yep. You don't absolutely have to, but I think it makes it a lot easier. So what do all those add up to? A whole bunch of x's. Let's see. Four. Now what? Yep, thank you, Cam. So I'm gonna move everything over here. So this is all 0. 2x squared minus 8x plus 4. Divide by 2. You don't have to do this, but you surely can. So x squared minus 4x plus 2. So now I'm down to that. Now what? That's always an option to try. It doesn't always work, and I don't think that's gonna work, because it would have to be 2 and 1, and that won't give me 4. So there's nothing wrong with thinking about factoring and even trying to factor, but it doesn't always work, and it doesn't work in this case. So what am I gonna do? Yep, negative b plus or minus the square root of b squared minus 4 ac all over 2a. What's my discriminant? That's the number under here. What's all that under there add up to? 8? Oh, don't you dare cancel. But can we reduce that radical 8? So 8 is 4 and 2, 2 and 2. So 4 plus or minus what? What does this give me? Now can I redo, yeah, cancel factor, cancel.
Yes.
Take 2 out of everything. So my final answer is that. Now remember, if you wanna leave it over 1, that's perfectly okay. If you wanna leave the 1 in there, that's perfectly okay. You don't need either one of them, but it would be okay. There is your final answer. Boy, that was kind of a mess. Look at that. Everybody okay? All right, try C. See how far you can get C. By yourself or with your partner there. Oh, guys, you gotta get woke up in here a little bit. Everybody's kind of drowsy. What'd you decide to do with that problem, C? This one, did you get it set equal to 0?
Yes.
Okay, so what are options?
Quadratic.
We could use always use the quadratic formula. I think this one actually does factor, but you don't have to factor it. You could use the quadratic formula. How does it factor? -5 plus 1, good, I heard somebody say it, which means x equals 5 and x equals -1. Now, if you do the quadratic formula, you will get those exact same answers. It'll all work out where this is a perfect square and you'll just end up with that answer. Okay? And then the last one looks like this. It looks a little bit different. What do you think might be a good idea here? So I'm gonna add the 4x squared, or add the 3x squared over here to this side. And then I'm actually gonna add the 5 over and not get a 0. I could totally get a 0. And if you did get a 0, A would be 4, B would be 0, and C would be -15. So you can do the quadratic formula on that if you want. What am I thinking about doing here? We talked about some of these in the last unit. What am I thinking about? Square rooting both sides. Yeah, that's what I'm thinking about doing. Now, it's just easier and faster for me. If you want to do the quadratic formula, if you get it set equal to 0, A is 4, B is 0, and C is -15. Crank it out. What's the square root of 4x squared? 2x. And then if I do it this way, I've got to remember the plus or minus. Remember that? And so x equals plus or minus √15 over 2. All right with everybody? And by the way, if you do the quadratic formula, that's the same answer you'll get. Uh-oh, turn the page. What do you notice? Section 1-2. That means your 1-1 homework is due on Wednesday, or Thursday. Your 1-1 homework is due on Thursday. All right, here we go with 1.2. Which are functions? What do you remember? What do you think about A? Yes or no?
Yes.
Yes. Why is it yes?
Because they won't cross.
It passes the vertical line test. If we draw vertical lines down through it, each line only hits one time. All right, what about B? No. For the same reason, only it fails, right? Because when you draw a line through, it hits twice. That's called the vertical line test. How about C?
Yes.
That's a yes. How about D? No. And E is always a little bit confusing. E is just the red curve. Just the red curve. That's a yes. And F is a, is there anybody that doesn't remember how the vertical line test works? Pass the vertical line down through. If it only hits one time, it's a function. So every vertical line only hits one time. All right, number 2, this is an extremely important section. Somewhere along here or on another sheet of paper or up here or something, I need you to write down the rules for domain. There's only 2 of them. You need to write these down. You need to know that these are good. If your problem has a denominator, it cannot equal 0. I think you know that already. You can't have a 0 in the denominator. Stuff you're getting, I'm starting to get a little angry here. I need you not to be doing homework. I need you to be working on homework. So you're doing homework. And number 2, the second rule. First rule is no 0 in the denominator. Denominator cannot be 0. The second rule is if you have a radical, this thing right here, the thing under the radical, must be greater than or equal to 0. So whatever is under the radical has to be greater than or equal to 0. Because if what's under the radical is less than 0, we'll have an I. And we don't want any I's. We're talking about functions, we're talking about real numbers. So those are the 2 rules. Alright, so let's find some domains. Letter A. What's the domain? Well, does letter A have a denominator? Nope. Does letter A have a radical? Therefore, it has no issues, and the domain is all real numbers. This means all real numbers. Anything goes. Negative infinity to positive infinity. All real numbers are your domain. What about B, however? Does B have a denominator? Nope. But B does have a radical. And the rule says whatever is under the radical has to be greater than or equal to 0. Which means that x has to be greater than or equal to negative 5. Would you agree with that? if you wrote that in interval notation, think about what that looks like. What would that be in interval notation? X has to be greater than or equal to -5. Bracket 5, or -5 to infinity. Is that okay? You see what I'm doing? I'm just looking at my two rules and I'm applying them to the problem. Alright, let's look at C. Does C have a denominator?
Yes.
Yep. So whatever the denominator is, it cannot be 0. Is that right? So that means X cannot be -5 if I subtract 5 from both sides. Now, I'm okay with you leaving that like that because to write it as an interval is wacky. Because basically what we're saying is everything's okay except -5. So negative infinity to -5 or -5 to positive infinity. That would be the interval notation for this. I'm okay if you just leave it like this. But that would be the interval for it. Alright, what about D? Here are my rules. Does D have a denominator? So whatever the denominator is, cannot be 0. So 4x cannot be 1. And x cannot be 1/4. Sure, you're solving that equation, guys. Come on. X can't be 1/4. So the question is, what's the domain? And the answer to that problem is everything except 1/4. Now, E is a challenge. So I'm going to hold up on E for a minute. We'll come back and talk about it. Let's look at F. Tell me what you think about F. Gives you your rules. Does it have a denominator? And the rule is, whatever your denominator is, cannot be 0. Which means when I solve that, x cannot be 0, because 0 divided by 3 is 0. So that's your domain. Everything except 0. Here are my rules. Does G have a denominator? Whatever is in the denominator cannot be 0. Have you ever seen anything that looks like this before? X squared minus 9? What is that? The difference of squares. So x minus 3, x plus 3 cannot be 0. So what does that mean? X cannot be positive 3, and x cannot be negative 3. So your domain is everything except those two numbers. You could let x be anything you wanted but not those two numbers. Okay, here's the biggie. And why is this a biggie? Well, does it have a denominator? So, x minus 2 cannot be 0. That's the rule. Which means x cannot be 2. Alright? But it also has a radical. And we know that whatever is under the radical has to be bigger than or equal to 0. Which means x has to be bigger than or equal to negative 5. So there are two pieces to this. We haven't had one like that. Why are there two pieces to that? Because there was a denominator and a radical. Each of those is going to give you part of your domain. Obviously, if I have both of these, then I'm going to have a two-part answer. All right, how about I? It has a radical. So that means the rule says whatever is under the radical has to be greater than or equal to 0. So I'm going to subtract 2. And then what?
Divide by -1.
And what happens when I divide by -1?
Sign change.
The sign changes. So x is less than or equal to 2. All right, will you try J, and then we'll go back and talk about E, it's wild and wacky. Try J. See what you can come up with for your domain. Anybody come up with an answer you're willing to share? Bingo. Eli's got it. He says whatever is under the radical has to be greater than or equal to 0. So 3x is greater than or equal to -1, and x is greater than or equal to -1/3. Yep. That's it. Now, what makes E hard? I'm going to tell you right off the bat that E, the domain, is all real numbers. And you're looking at it and saying, wait a minute, it has a denominator. You're right, it does. But why does it not matter in this case? This is a really tricky problem. Why does it not matter? What?
Because there's an exponent in the denominator.
Well, what happens when you square something? It automatically becomes positive. If you square a number. So can you square a number and add 1 and have it equal 0? Could you square something add it to 1, and get 0. No, because what happens when you square it, it becomes positive, and then when you add 1, it's even more positive. No way will it ever be 0. So because that denominator can't ever be 0, there are no limitations on it. That's a tricky one. That won't be a test question or anything. That's kind of a tricky one. Okay? So before we head to our next step, what are the 2 rules for domain again? Denominator cannot be 0. Denominator cannot be 0. And if there's a radical, whatever's under it has to be greater than or equal to 0. Right? 2 easy little rules. Really important stuff. Alright, so we are heading toward some graphing now. And what we just talked about, believe it or not, plays very heavily into our graphing. We are not going to graph this whole thing right now. We're going to learn how to do it in steps. First part today is to find what we call the vertical asymptotes. The vertical asymptote. Have you ever heard the word asymptote before? The word does have a P in it, but the P is silent. So it's asymptote. Okay, asymptote. And an asymptote is simply, well, for our purposes, it's a line. It doesn't have to be a line, but for us, it's going to be a line. A line that the curve approaches but doesn't intersect. So an asymptote is like a wall, and the curve comes closer and closer to it, but since it can't cross it, it has to either curve up or curve down. That's what a vertical asymptote is. Where are the vertical asymptotes? Well, it's very, very easy, and it's tied directly to domain. What do you know about anything in the denominator? Can't be 0. So what would be the domain of this problem right here? What would be the domain? X minus 1 cannot be 0. So x cannot be 1. Whatever x cannot be is your vertical asymptote. So this problem has a vertical asymptote at the line where x equals 1. Whatever x cannot be, when you do domain, denominator cannot be 0. So when you figure that out, x cannot be 1. That's where your vertical asymptote is. Vertical asymptotes are cannot be's. Whatever you can't be. So what about, and right now all we're doing is graphing the vertical asymptote. We're not graphing any more of the picture, just the vertical asymptote. Where is the vertical asymptote in problem B? Well, there's a denominator, and I know that the denominator cannot be 0. That's domain. I told you it's hugely important. It is. Denominator cannot be 0. Which means what? X cannot be 5/3. So I'm going to graph my vertical asymptote at x equals 5/3. Now, sometimes we have a little bit of confusion because some of you are thinking, wait, before you just said x can't be 5/3, and then you graphed x equals 5/3. Yes, the asymptote at 5/3 tells me x can't be that, because x can't be vertical asymptotes. Can you do C? Can you figure out where your asymptotes are? Vertical, I should say, vertical asymptotes for C. Anybody have a thought? Very good, Eli. Eli says, my denominator cannot be 0, ever. That's the difference of squares, which means x can't be 2 and x can't be negative 2. So this wild and wacky picture has 2 vertical asymptotes. It won't be too long and you'll be able to graph these things. But step 1 is figure out where the vertical asymptotes are. In a little bit, probably tomorrow, we'll go to horizontal asymptotes. We'll add that instead. All right, everybody okay with that one? All right, let's go to D. Anybody have an idea where to start here? Factor, yep. How does that factor? X, what'd you say? Plus 5 minus 1. What is always my caution when we factor? Take a minute and double check it. Does this work? What's wrong with it?
It's a positive 4.
Yeah, this is a positive 4 and I need a negative 4. So how can I fix that? Change the signs. You have to just change these guys. And it'll be fine. Now it's fine. So where are my vertical asymptotes then?
One's at -1.
Can't be -1, yeah. And can't be
Positive 5.
+5. Basically, this is the same question as domain, except if it were a domain question, you would say x can't be 5, x can't be -1. Because whatever x can't be is your vertical asymptote. Now, E will wake you up because E is a little bit different. Take a look at E and tell me if you notice anything different about it than the other problems that we've been doing. Well, does the denominator factor like the one we just did?
Yes.
Now it is a plus though. So x
Plus 5.
plus 5 minus 1. What do you notice about the numerator though? It also factors. So this hasn't happened to us. If you look back at all the other problems, the numerator has never factored. It's just then whatever it is. This one factors. Okay, what difference does that make? Exactly. We now can cancel. And our problem reduces to this. Now that opens up a whole new idea. First of all, the old idea. Where is our vertical asymptote? There's only one. Because there's only one thing in the denominator, right? Where's my vertical asymptote? -5. Lincoln, you okay, honey? Okay, put your paper up on your desk, please. Go ahead. Now, here is the deal. When something cancels out, in actual math language, it's called a removable discontinuity. We're going to think of it as a hole in the graph. If you can cancel out something in your denominator, it will leave a hole in the picture. And the hole will be at the x value that canceled out. So the x value of the hole is 1. Make sure that digests. 1. Always the opposite of the parentheses, right? Now, it's a point. So I know the x is 1 because the x always comes from what canceled. What is the y? Any idea how we might find the y? Plug it in, plug it in. Only when you plug it in, you have to plug it in your small problem, your reduced problem. So if I put a 1 in here, what do I get? If I plug a 1 in, on top I have a 2, and on the bottom I have a 6, which reduces to 1/3. So remember, we're heading toward being able to graph these things. At the point 1, 1/3, there is a hole in the picture, an open dot. FYI, you won't see that on your calculator. This is one place where humans are better than the calculator because the calculator can't deal with that. Alright, so back up. Where do holes come from? When is the only time I'm going to have a hole in my picture?
If you cancel.
If I can cancel. And if you can't factor your numerator, you're not going to be able to cancel, right? Okay. One more, and then we'll be done. Where am I? Let's look at F. What is your first step with problem F?
They both factor out.
We both factor, alright, so let's do the bottom first because it's the easiest. What's x squared minus 16?
X plus 4.
X plus 4, x minus 4. Okay, good. Alright, I'll take a minute on the top. How does the top factor?
X plus 4. X plus 5.
Plus 4 plus 5, I heard.
Plus 4 is
Nash, you given her? Okay. notice here, you're gonna be able to cancel, which means that this is our actual picture now that we're graphing, this guy right here. That's what's left. Does he have a vertical asymptote?
Yes.
What is it? Positive 4. X equals 4. Vertical, all asymptotes are equations. X equals or Y equals. Verticals are X equals 4. We intersect the x-axis at 4. However, we cancel. And whenever you cancel, your picture's gonna have a hole in it, a gap, empty circle. Where will this one be? What is the X value?
4.
No, not 4, negative 4. Remember, the X value of the hole comes wherever you cancel, whatever you cancel. So since I canceled out X plus 4, my hole will be at negative 4, always the opposite of the parentheses. Just like your asymptote was at positive 4, opposite. Okay, how do we find the Y coordinate of our hole, our removable discontinuity? Plug it in that number, and where do we plug it in? The simplified equation. So negative 4 plus 5 is what? 1. And negative 4 minus 4 is negative 8. So we have a hole in our graph at negative 4, negative 1/8. All right, we'll do that last one. It's a monster. Look at it. We'll do that next time. Next time, we'll also do a practice quiz, and then the time after that, we'll have a quiz over domain. What are the rules for domain?